Good afternoon, student. Welcome to all. This is Professor Meenakshi Pancha. Today I am going to explain more about the block diagrams. This is the block diagram of 8051 microcontroller. In last class, we have seen about the ALU, accumulator and program status word, but I have not explained with the PPTs. It may be not clear some topics for you guys. So let's see quick review of those once again. So see the figure. This is the block diagram of 8051 microcontroller. Here I have highlighted the ALU part in a yellow color rectangle box. This is the ALU. In the ALU, such type of operation is going. So first of all, know about what is the ALU. ALU is arithmetic and logic unit, performs 8-bit arithmetic and logical operations, which performs arithmetic and logical operations on 8-bit data. And here you can see, again here there are two registers. One register is temp1 and temp2. There are two registers. Those registers called as a temporary register. The operands on what instructions the operation is going to perform is stored in here. First comes in this temporary register and after comes into the ALU. The ALU access these two temporary registers and start doing operation. See in this GIF picture here, this is the instruction pointer. Instruction pointer, what it do, it will send the address of the memory where the instruction is stored. This is the internal memory. Here the instruction is stored. These are the address. So the instruction pointer, what it will do, it will send the address through address bus and reach here. At the particular address, the instruction will be accessed and pass through this instruction register using this bus. So instruction register, what it will do, it will store the instruction here first and after it will decode in the decoder unit. The green part is a decoder unit. This decoder accesses the instruction from the instruction register and decode the instruction and understand what type of operation should be performed, and that command will send to the execute unit. This execute unit performs such operation provided by the decoder unit and it performs the operation. After performing the operation, result will be stored in here. This is a accumulator register. So now I think you guys have cleared the things. Just a minute. Okay, I have taken attendance screenshot. So let's see. I think the concept is clear for all of you guys. One thing I have to mention, these temporary registers, okay, these temporary register cannot access by user. User cannot access by these two temporary registers. So let's see accumulator. What is the accumulator? Accumulator is a register which is 8-bit register. It has address of E0H. So note here. So let's see the accumulator. What is the accumulator? Accumulator is a 8-bit register. It is having an address E0H. E0H is the address of the register where it is placed in the memory. It has a bit addressable register. There are several different types of register. We will see in those sections. So for time being, just remember accumulator is a bit addressable type of register. Accumulator holds the source operands and receive the result of arithmetic operations including addition, subtraction, integer multiplication, division and Boolean bit manipulation. What it will do? After performing the operation of ALU, the result will be stored in an accumulator. It is also used for data transfer between 8051. After putting the result into the accumulator register, how we can access? So it will after transfer the data and acts as a data transfer to the external memory. It contains many and it also performs several operations like rotate and swap. It is also used along with the register B for multiplication and division operation. So I have mentioned here this rectangular box shows the place of accumulator where placed in block diagram. So now see B type of register. This B register is used with a accumulator register for multiplication and division operation. For other instruction, it is treated as a scratch pad register. While performing the operation of ALU, result will be put in a accumulator. But some operations, for example, multiplication, division, there are several results. If we are doing division operation, the remainder may not be a zero. Hence, we get two types of answer there. So it will help for putting the answer in register B. The address of register B is F0H. It is also bit addressable register. So once again we see about program status word. So many instruction affects the status of flags. So first of all, we have to understand about what is a flag. Flag is a 1-bit register which provided to store the status of the result of some instruction. While performing the arithmetical and logical operation, there are many conditions are arised. So that based on that condition, these flags are going to affect. So these flags are 1-bit register. It will store only single bit, either high or low. These such type of groups of flags is called as a program status word. 80, it is a 8-bit. The flag, the program status word is a 8-bit register. It contains a flags it contains a flags based on mathematical operations, user programmable registers, selected bits that identify the register's bank that is currently in use. It will shows the such type of notification. When the program status word will be reset, this value will become 00H. 8051 having a 4 mathematical flag that includes carry flag, auxiliary carry flag, overflow flag and parity flag. These are this carry flag, this carry flag, this auxiliary carry and overflow flag and parity flag. These are called as a maths flags. Let's see one by one. So what is the carry flag? Carry flag will be set 1 when there will be a carry or borrow of the result. After performing operation, the result will be stored in accumulator. So if there is any carry on 7th bit of the result, then this flag will be going to set to 1. So next flag is auxiliary carry. What is the auxiliary carry flag? It is going to set whenever there is a carry out of lower nibble to higher nibble. Nibble is nothing but 4-bit. 4-bit is called nibble. 8-bit is called byte. When after doing an operation at the 4th bit, if there is a carry generated, so that time this carry flag is going to set to high. Next one is, let's see first overflow flag. What is the overflow flag? Overflow flag will be set to 1 when arithmetic overflow has occurred. Significant bit has been lost because of size of the result exceed the capacity of the destination location. Here what is the destination location? Here destination location is the accumulator. Accumulator is only 8-bit register. If the result is overflow, it will come beyond 8-bit. Then what will do? 1 bit will be lost. So that condition should be get notified by this overflow flag. If such condition is occurred, then overflow flag is going to set. Then another flag is called parity flag. Parity flag is going to set when the result has even parity. When even number of ones, it counts how many number of 1 is present in the result. If the number of ones after counting, if the number of result 1 is an even type, then this parity flag is going to set. So this is the RS0, RS1. These are the bits used for selecting the register bank. See here, if the register RS0, RS1, these two states are 0, 0, then the bank 0 will going to select. This is the address of register bank 0. We will know how the address will be given here in a brief discussion on the memory section. So if 0, 1 is set, then bank 1 will be selected, 1, 0 will be set, then bank 2 will be selected, and 1, 1 is set, then bank 3 will be selected. So next one is user flag. This F0. The F0 is called as a user flag. What is the user flag? It is a itself is having a three purpose of user flag that can be set to 1 or cleared by using a programmer. So programmer can decide to use this user flag according to their application requirement. The user flags are named F0 or it may be named as GF0 or GF1. The program status word contains the user flag F0 while GF0 and GF1 flags are stored in Pecan register. So this is used for future purpose. Currently there is no operation mentioned for this flag. So let's see next. This is again description of the flags, how is going to set. See here, this is GIF file. Actually, this is not working here. This is working here. See how this flag is going to set here. These are the 7 bits here. According to condition, these flags are going to fill here. So now let's see clock and oscillator circuit. So 8051 has an on-chip oscillator, but it needs an external clock to run it. Itself on the memory chip, itself on the microcontroller chip, there is an oscillator. But that how to run that oscillator? We have need external clock to run it. So oscillator circuits, what it will do? It will generate a clock pulses so that all the internal operations should be synchronized. There may be many tasks are performing inside the microcontroller. All the operations are synchronized by using a clocks. So this clock will be provided by the oscillator circuit. Where is the interfacing that oscillator circuit? Here in the pin number 18 and 19, these two are in between these two pins. According to our application, the oscillator or resonant network will be going to connected. This is a resonant network, oscillator resonant network, which is having a crystal type oscillator. Crystal type oscillator with the capacitor. There are 2 capacitors are used. So this name of oscillator is quartz crystal type of oscillator. The capacitors are used in order to stabilize the network. So stabilizing this operation of this network, these 2 capacitors are used. The size of these 2 capacitors are 30 picofarad. Each capacitor is having a 30 picofarad size. See here, for the quartz crystal will generate such type of pulse. Here, two pulse are called as one state. So one machine cycle, for executing the instruction, there are many pulses are required. So how we can say how many pulses are required? So we can consider the machine cycle. This is a machine cycle. There are totally 6 states. 6 state is called as a one machine cycle. One state includes 2 pulse. See, starting here, consider from the starting 2 pulse. 2 pulse is called 1 state. So total 6 state is equal to 1 machine cycle. So how we can, in between in our application, how we can say what time should we need for execution of my instruction. So this is one of the formula. Using that, the time can be calculated. Here T is a time required for execution of the instruction. C is the number of cycle, how many number of cycles should be taken, into 12 divided by crystal frequency. The frequency using what type, the crystal, what type of frequency will be generated. So that value will be put here. So using this formula, we can calculate the time required for the execution. So the time requirement is depend upon the instruction set. Some instruction, simple instruction set, maybe take a one cycle or one cycle machine cycle, or some instructions will be taken 2 machine cycles and some will be taken a 4 machine cycle. It is based on the type of the instruction. So next, see program counter. So what is the program counter? Program counter is a 16-bit register. It is used to hold the address of instruction in the memory, or information of address it is used to hold. It contains the information of the address, not a direct address. It contains the information of address of the memory. It functions to keep the track of the execution of the program. If one task is starting to execute, it will keep the track where it is started, what kind of a command should we execute next, what is happening, all track it will keep. The program instruction bytes are fetched from the location in the memory that are addressed by the program counter. Whenever the power supply is switched on, the program counter reset to 000. See, while you are doing an operation, suddenly if you switch off the power, but after that the program counter will be itself reset to 000. It can access the memory location from 000 to FFFF. The program counter is automatically incremented after fetching a byte of information from program memory. If one instruction will be executed, it will automatically incremented and keep the record of track. The program counter is only a register that do not have any internal address. We have seen in the last, there may be so many address. For example, we have seen that accumulator having a particular address and register B is having particular address, but program counter itself, it does not have any address. So this is the block diagram I have shown. This rectangular blocks shows the area where it is program counter is placed. So let's see next. Next is a data pointer. What is the data pointer? Data pointer is also a 16-bit register. It is used to hold the address of data in the memory. Program counter, what it does, program counter will hold the information of address in the memory. But here data pointer, what it will do? It will hold the address of the data memory. It can be used as a 16-bit data register or 2 independent 8-bit register. We can use as whole 16-bit register, or either according to our application we can also use half of 1 bit also. If my application require data point only 8-bit data pointer is required, we can access individually one by one. So what is the data pointer will does? It is a base register in case of instruction handling lookup table and external data transfer. It acts as one of the base of the register where when instruction handling in the external data transfer. The data pointer register can be accessed separately as a lower 8-bit and also higher 8-bit. We can access these data pointers separately. If I want to access only this type of data pointer, I can access. If I want to this type of this data pointer, I can access separately. The data pointer register can be accessed separately. DPL and DPH are the two 8-bit register. See, the address of DPL is 82H. See here, this is the if exams are going in in objective type manner, then the address should be, you guys should be remember. If he may be asked or arise a questions on based on the address, he may ask what is the address of this DPL register. So the address should be kept in mind. Keep in mind. So the address of DPL is 82H and the address of DPH is 83H. The data pointer does not have any internal address. Instead, DPL and DPH. See its address. We can find the data pointer as DPH and DPL. If I want 16-bit data pointer, it does not have address for the 16-bit DP data pointer. We can access one by one. So next come to memory organization. So see what type of memory has been organized in a microcontroller. First of all, see the internal memory structure. Here the figure shows the basic memory structure of the microcontroller. It can access up to 64K byte of program memory and 64K of data memory. So see the student, due to the time limit of Zoom, it will going to end automatically, and please rejoin, take a 10-minute break and please rejoin after 10 minutes. Okay, take a 10-minute break and please rejoin at the 3 p.m. So let's discuss while it is going to shut down automatically. See the memory organization here. Totally 64 kilobyte of program memory and 64 byte of data memory. So total we are having 128 byte of the internal data memory. So each memory has a separate addressing mechanism and it is also has different control signals and different function. Each memory we can access by using different mechanism and it's itself having a different control mechanisms, but with different control signal. So let's see one by one. This is the program memory. This is the program memory. It is having a 64K of external and 64K of internal program memory. If I want to access this program memory, I should keep the access enable pin to VSE. I have to connect this access enable pin to VCC. Then the program fetches the address from 0002 0FFH as direct internal memory. See 0002 00FFF. If EA bar pin is connected to high, then this memory is going to access. If EA pin is grounded, then all the address from 0002 to FFF is going to X. See here, if EA is you did connected to high, then these memory will be going to access. If you EA pin is make it low or connected to ground, all the memory will be going to access. This is the program memory organization, how we are going to access. Now let's see about data memory. So 8051 microcontroller here can address up to, it is also address up to 64 KB of the external data memory. As shown in figure, here the command MOVX is used to access the external memory. How can access the external memory? By giving a command MOVX. The internal memory space is divided into 3 blocks. The internal memory place is divided into 3 blocks. First one is 0 to 7FH, upper 128 byte, and 80H to FFH. And there are some special register is also there. So we can see detail when going to that section. So now we can see information about internal RAM. Internal RAM, it's having 128 byte of the internal RAM, and it can be organized in 3 group. First groups comes 4 register banks of 8 byte in each group consist. Here there are 3 groups, group 1, group 2, group 3. First group contains a 4 register banks B1, B2, B0, B1, B2, B3. These are register bank group, and second one is called as a bit addressable group, and third one is a scratch, or we can say general purpose RAM area. From the memory address, there are 4 register banks in first group. In first group there are 4 register bank. How the each bank is organized? See in this figure. There are a total 8 register in a particular bank. See, the bank 10 contains 8 register. It starts from R0 to R7. This is the address of this register. Register bank 0, register 0 contain 00H and 001H, 02H, 03H up to 07H. There are total 8 register which itself having 8 bit. These are the 8 bit register, and of 08 at the address, the register starting at the address 08, it comes under in bank 2 register. So first we will see about the register, how they are organized in a particular bank. There are 4 register bank which are numbered from bank 0 to bank 3 in 128 byte of the RAM. Each bank is made up of 8 register. This bank is made for 8 register. This bank is made for 8 register, and this is also contain 8 register. This similarly these two also contain 8 register. So totally bank 0 contain how much? Total 32 register. Bank 0 contain total 32 register, which is addressed from starting 002. Last address is what? Last address is 1FH. It may be it may be important for the exam point of view. What is address contain the bank 0? Mention it. Then you should choose 00. This is a starting address, and 1FH is a last address of bank 0 register. The RAM location 00H and 007 are set aside for a bank 0. This one is set for bank 0 and R0 for the memory location 00H. Then second bank register being at, this is started from 08H to 0FH. And third bank register started from 10H to 17H. For selecting the register bank, 2 bits are used. What is that? RS0 and RS1. We have seen in program status word, there are 2 flags, RS0 and RS1. In the operation, how we are going to select? By selecting these 2 bits. If 00, then bank 0 will be selected. If 01, then bank will be selected. If 010, then bank 3 will be selected. So setting the RS0 and RS1 flag, the particular bank register bank will going to select. If any register bank is not selected, then program can be used memory from 00H to 01F. If nothing selected, by using this flag register randomly itself, it will selected anything, any memory from 00 to 1FH. So the register bank is 1 uses the RAM space by the stack. Then this is a major problem while program 8051. So this is one of the disadvantage. If the program status, there is stack, there is a one of area name is called as a stack, which is while doing some particular operation, the